what I would like you guys to start off doing is let's take just a moment to multiply these two binomials that we have at the beginning of the note. So we're going to distribute the 3x and we will distribute the -5. So take just a moment to do that. All right, Jace, when you distributed the 3x, what did you get? 9x squared and
15x.
plus 15x. And then when we distribute the -5, what'd you get?
Negative 15x.
-15x and
Negative 25.
-25. And what happens in the middle there? The 15x cancels out, so we're left with just 9x squared minus 25. Now, a couple of things that I want you guys to notice here. Like we just said, those middle two terms canceled out. And look at what we started with. What do you notice about what's in these two binomials that we started with? Morgan?
It's squared.
I'm talking about in here.
Oh, they were kind of
Yeah, they're kind of like the same. We have the 3x in the first two spots. We have a 5 in the second two spots. And what's different? What? Yeah, one's a minus and one's a plus. Okay? When we multiply binomials that are in that kind of form where they're basically the same, just one's a minus, one's a plus, they form what we call a difference of squares. So let's talk about what that means for a second. When you hear the word difference, what does that make you think of?
Two opposites.
What operation? No. You take the difference of two numbers. What are you doing? You're subtracting. This is a subtraction of two perfect squares. So if you look at what we have here, you see a subtraction, and then these are both perfect squares. Okay? So what we're going to be doing today is working backwards. You're going to be given the difference of squares. You are going to work backwards to get the two factors. All right, we've been saying this every single day. Factoring is like undoing. Oh, you guys are listening. Undoing multiplication. Very good. So, here's what we're going to do. I'm actually going to jump ahead just a second down to the rule for factoring a difference of squares. So you're going to have two factors, two sets of parentheses. We take the square root of the first term. Okay, so the square root of a squared is a. That goes in the first two spots. And then I take the square root of the second term. So what's the square root of b squared? B. That goes in the second two spots. And then I put 1 plus and 1 minus. 1 plus and 1 minus. Okay? That's the general idea, bless you, that we are going to work with here. Okay? So let's go back to the examples. X squared minus 121. So pay attention, okay? make sure that you have a difference of squares here. So do I have a subtraction?
Yes.
Do I have two perfect squares? Yes. Okay, so that means I'm going to be having two factors. I take the square root of the first term. Vanessa, what's the square root of x squared? X, so that goes in the first two spots. Then I take the square root of the second term. Nick, what's the square root of 121?
11.
That goes in the second two spots. And then I put 1 plus and 1 minus. And those are the two factors. What questions do you have? All right, let's look at the next one. So again, we have a subtraction of two perfect squares. So I know that this is going to factor to two factors. Take the square root of the first term. Colton, what's the square root of x squared? X, so x goes in the first two spots. Jadelyn, what's the square root of 9? 3, so 3 goes in the second two spots. And what goes in the middle? What? A plus and a minus. Yeah? Okay, the next one's a little tougher. 4x squared minus 49. So first of all, do we have a difference?
Yes.
Do we have two perfect squares?
Yes.
Yes, we do. Okay, so we're good there. Now, in that first term, what's the square root of 4x squared? Soren?
2x.
That is 2x. So that goes in the first two spots. The square root of 4x squared is 2x. You take the square root of the 4 and of the x squared. Jacob, what's the square root of 49?
7.
7, so that goes in the second two spots. And what goes in the middle? A plus and a minus. A plus and a minus. All right, I want you guys at the bottom to try these three. All right, so take a couple of minutes. I want you to try these three. Do that now. Alrighty, on the first one. So this one's a little bit different too because we not only have a variable with the first term, but we also have a variable with the second term. So again, let's check. Is this a difference?
Yeah.
Are they both perfect squares?
Yeah.
Yes. All right, so two factors. Justice, what's the square root of 9r squared? 3r, so that goes in the first two spots. Logan, what's the square root of 100s squared?
10.
Close.
Oh, 10s.
10s, very good. So 10s goes in the second two spots. And what goes in the middle? A plus and a minus. Good, good, good. All right, on the second one, is this a difference?
Yes.
Are they both perfect squares?
Yeah.
Yes. Yasmin, what is the square root of 36x squared?
6.
Close. What did you say?
I said 6.
Yeah, not quite. That's the square root of 36, but I want the square root of...
7.
No. Square root of 36x squared. 6x. So 6x goes in the first two spots. Alex Baiting, what's the square root of 49?
7.
So that goes in the second two spots. One's a plus, one's a minus. All right, last one. Is this a difference? Is this a Did I get ya? Not a difference. This is not a difference of squares.
What? Oh.
It's not a difference. That has to be a minus sign in the middle. Not a difference of squares.
So we don't solve it?
So you cannot factor it. No. I gotcha.
That's rude.
I don't know if that's a typo or not, but we're going to go with it. Just so you can see that you really do have to pay attention to what you have in the middle. All right, real quick, what I want to do at the bottom of your notes is I want to kind of summarize the types of factoring that we have talked about. So at the bottom of your notes, you should have plenty of room. Let's talk about the types or tips for factoring. Because at this point, we've talked about 4 different ways to factor. So it's kind of hard once they're all thrown together. So once these types of factoring are all kind of thrown together, it gets kind of confusing what we're going to do. So just a couple of tips to help guide you as you work. The first thing that we should always do is check for a GCF. Okay, so that's the first type of factoring that we looked at, and we looked at that first for a reason. So we're going to do that first. Then from there, if it's not a GCF problem, it's kind of based on the number of terms that you have in your problem. If we have 2 terms with a subtraction, that's the difference of squares that we just talked about. And we should say perfect squares too. It can't just be any 2 terms. It has to be a difference of perfect squares. If there are 3 terms, we're looking for what multiplies to C and adds to B. So like x squared plus 6x plus 8. Okay, what multiplies to C and adds to B, like we did last time. And then finally, if we have 4 terms, you're going to use grouping. Okay, 4 terms uses grouping. So let this kind of little summary be helpful to you as you look at different types of factoring. Okay?